Basic Principles of Overunity Electromagnetic Machines. A Scientific View into the World of Free Energy from Electric Charges and Magnetic Fields by Jovan Marjanovic, Master of Science. Johann W. Goethe said that the biggest secrets were the open ones. You look at them but you do not see them. The same is true with the electromagnetic field. It is known fact that after switching off an electromagnet, its magnetic energy will be returned back to the circuit, usually as a spark. What was missed is the fact that the magnetic energy performed work by attraction of an iron bar and didn't consume itself. This work, minus heat losses inside the circuit, is free energy or overunity energy. The goal of this book is to unlock the secrets of overunity and to teach people what is overunity and how it works. The reader will learn how to make new ultra-efficient electric motors and generators and how to improve existing patents which use permanent magnets. Basic Principles of Construction for Overunity Electro-Motors and Generators. Jovan Marjanovic, Bachelors of Science in Electrical Engineering. Email, jmarjanovic@hotmail.com. November 12, 2009, Novi Sad, Serbia. Updated on October 23, 2011. Abstract. The goal of this work is to point out some important facts in construction of overunity electro-motors and generators, where output energy of the machine is greater than the mechanical energy invested on the input side of the machine. If some of the output energy of the generator is directed to the input side of the machine, then perpetual motion can be achieved or perpetuum mobile. In this work the author will discuss principle of using unbalanced magnetic forces for construction of overunity machines, principle of using movable magnetic shields for construction of overunity machines, possibility of using high-speed rotors to generate voltage in the generator to avoid magnetic drag caused by Lenz's law, methods of combining magnetic fluxes for construction of an overunity electromagnetic machine, failure of the law of thermodynamics in a case of kinetic energy, balance of a river and logic of cosmic ether as energy source. Introduction. In this work overunity machines with the usage of magnetic fields only will be discussed. Machines like Thestatica, which uses electrostatic field or ether energy generators like the legendary Nikola Tesla's electric car which used vacuum tubes and Edwin Gray patent 4,595,975, is not subject of discussion here. The above-mentioned patent has been explained in a book by Dr. Peter Lindemann 1. This work is logical continuation of the author's last work 2 published on the same site as this one 3. The author has continued his research of this subject on the internet and has found some interesting machines patented many years ago, as well as some comments and explanation of these machines by other people. The author has learned some things from these people, but also found something lacking in their explanations and even non-understanding of some important facts of magnetism. In this work there will be minimum of mathematics in order that a wide range of people can easily understand what will be discussed in this work. The author will also include and discuss several patented machines to show variations and development of the principles and also that these ideas are not empty imaginations, but right principles with patented devices behind them. The principle of unbalanced magnetic forces. The common belief is that a magnet cannot perform useful work by itself. Partially, this is true. If an iron ball is dropped near a magnet it will be attracted by some force to the magnet. The work is defined as product of force and the path passed in the same direction. In picture 1 below, it is obvious that there is a force and path passed. However, once the ball reaches the magnet it is the end of the story. To repeat the experiment it would be necessary to invest the same amount of work to put the ball back the same distance from the magnet. However, if it would be possible to switch off the magnetic force, or at least to diminish its strength, then the ball could be put back with less work invested. The gain would be obvious. In picture 2 below, is one invention of John Bedini. The device is using the repulsion force of magnets because the same poles of magnets in rotor and yoke are facing each other. In order to have some momentum on the rotor the yoke must be movable to create force with variable intensity. The rotor can be pushed by pushing the yoke close to it and then returning it back to allow next magnet to Approach north pole of the magnet in the yoke. It is not known to the author how much energy should be invested in moving the yoke and how much energy is gained in rotor rotation. The picture above is just a school example of causing the movement by unbalancing magnetic forces. Another way of causing unbalance is to use the vibration of an iron plate. In the year 1879, Gary Wesley patented an electromotor which used the principle of neutral line of a horseshoe permanent magnet. He found that an iron plate below the neutral line would behave as if it was part of magnet itself, just a little bit separated from the main part of the magnet. If the iron plate was above the neutral line, then the magnet would induce opposite magnetic poles in it. When a thin piece of iron dwells on the neutral line, it will not take magnetism into itself. By moving the plate up and down in oscillatory way, magnetic poles of iron plate would change alternatively. Gary claimed that with small input power his machine could generate significantly greater power on the output. Below is a picture of neutral line for a horseshoe magnet. Gary had used the neutral line and made a machine he called a motor, which is actually generator. It had an iron plate with wire coiled around it. The iron with coil was then separated from the horseshoe magnet by paper. If the iron was vibrated around neutral line, it would change its polarity, and that change would induce alternated electromotive force in the wire. Without a load, the generator doesn't stop vibrating once started. The iron would oscillate continuously because change of its poles would alternatively attract and repulse it towards the magnet. Canadian patent number 10239, July 16, 1879, Wesley W. Gary. He also used springs below the plate and the weight of the plate itself to control oscillations of the plate. The next way to cause unbalance of the magnetic force is to magnetize the iron core attracted to the magnet just enough to cancel attraction of the magnet towards the iron core. The idea is illustrated in pictures shown below. In picture 5, a permanent magnet is attached with a firm grip to the non-energized metal core of the electromagnet. In picture 6, there was applied just enough current to release the magnetic grip and permanent magnet falls away. The basic idea is to use minimal current, just enough to create a small opposing magnetic field. Using a strong current to oppose a permanent magnet would be useful to do once, but if it was necessary to do it many times, then pulsing current would behave similar to alternating current and would create heat losses in the electromagnet due to hysteresis and whirling eddy currents. Robert Adams, from New Zealand, designed and built an electric motor using this principle. He used permanent magnets on the rotor and electromagnets for the stator. The north poles of the rotor were attracted to the iron cores of the stator. It was driving force of the motor. With special logic, he pulsed the electromagnets just enough to stop the attraction, once the pole of the magnet came in the middle of the core of electromagnet. This way, the magnet would pass the core of the electromagnet by inertia. Once the magnet was a safe distance from the electromagnet and closer to the next electromagnet, which was turned off, the current would be stopped and the magnet would continue to move, attracted by iron core of next electromagnet. Adams claimed that quotient of efficiency of his motor was 800%. In order to have it, he also used coils of electromagnets to pick up electricity generated by approaching magnets before turning on electromagnets to create opposing force. After turning off any electromagnet, its magnetic energy would be released back in the circuit, usually as a spark. This is called back electromotive force. Adams also collected it and sent it to a battery for charging. Canadian inventor Bill Muller had discovered one special case between a permanent magnet and iron. When three steel balls in the vicinity are attracted to a permanent magnet and then as impact occurs steel to steel, one or more of the steel balls will repel and one will remain attracted to the magnet. Bill concluded that the balls had been repelled without invested energy and in that case, had violated Newton's laws. It can be seen very easy that the principle of the neutral line of Gary Wesley is the same as special case of Bill Muller. Bill constructed a generator which included the logic of both Gary Wesley and Robert Adams yet was still unique, see picture below. Jovan Marjanovic Basic Principles of Construction for Overunity Electromotors and Generators case, had violated Newton's laws. It can be seen very easy that the principle of the neutral line of Gary Wesley is the same as special case of Bill Muller. Bill constructed a generator which included the logic of both Gary Wesley and Robert Adams yet was still unique, see picture below. His generator had an odd number of electromagnets and an even number of permanent magnets. His magnets in the rotor were positioned off-center in relation to the stator coils. His magnets were positioned with alternate polarity N, S, N, S. He claimed that his latest device produced 400A and 170 VDC on output for 20A and 2 VDC drive current. The principle of movable magnetic shield below is a picture with a coil, 2 magnets and an iron plate as a magnetic shield. On the first setup, the iron plate will stop any influence from the right magnet to the coil and the left magnet will induce a south magnetic pole in the coil close to it. The opposite north magnetic pole will automatically appear on the other side of the coil close to the shield. On the second setup, the shield has been moved to the left and right magnet will induce a south magnetic pole in the coil close to it. A north magnetic pole will be automatically induced on the opposite side, again closest to the shield. The conclusion is that magnetic poles of the coil have been changed by moving the magnetic shield from the right to the left. This alternate change of the magnetic poles will induce an electric voltage in the coil. So, here we have dynamic induction of electromotive force without moving either magnet or the coil. This method is not given in standard school or university books which explain Faraday's law of the induction. The next important thing to know is the behavior of the metal plate passing close to the magnet. The author found on the internet, a picture shown below and the following description of the process. The piece of metal passing the magnet loses no energy. The velocity of the metal increases as it nears the magnet, and decreases as it leaves, but both in equal amounts. So from frame 1 to frame 3, no energy is lost. You can prove this to yourself by tying a piece of metal to a string, taping a button magnet to a table, and letting the metal swing back and forth above the magnet. It does so for a long time, and only slows down due to air friction and energy lost in the string's vibration. Unfortunately, the description above is not quite true. Metal will lose energy also due to induction of eddy currents according to Lenz's law. The proof of the fact is Foucault's pendulum, as in picture 11. Between the two poles of an electromagnet a copper plate was hung and allowed to swing after being raised to some initial angle. Swinging was lengthy if no current was present in the electromagnet but stopped fast if the current was turned on. In the picture 11, B, eddy currents, induced by Lenz's law, can be seen. The magnetic force has a direction opposite to the movement of the pendulum plate. This force causes fast stopping of the pendulum's swing. Foucault experimented by cutting some slots in the plate as shown in picture 12. He found that the case, A, didn't prolong the swinging of the pendulum under a magnetic field, but that case, B, did. The reason is because the slots in case, B, cut the path of induced curling currents. The logic from picture 12, B, is used in laminated voltage transformers or in the core of electro machines. To reduce eddy currents means to reduce heating losses and drag on the rotor. Another way to minimize eddy currents is to increase electric resistance of the iron by adding up to 4% of silicium into the iron. This increase of electric resistance will not deteriorate the magnetic conductivity of the soft iron. The conclusion is, that for a magnetic shield, the same materials should be used as for transformers and cores of electric motors or generators. It would also be beneficial, if possible, to make shields of laminated slices like in picture 12, B. These methods would reduce eddy currents induced by Lenz's law and it would diminish drag of the moving magnetic shield. This would open a path for the construction of an overunity machine. Patented devices which used movable magnetic shield, John W. Eklund's stationary armature generator, U.S. patent number 3,879,622. Although Eklund called his patent a generator, it was actually a permanent magnet motor with 4 springs, 2 horseshoe magnets, soft iron and 2 magnetic shields shaped as on Fig. 2. Soft iron, 5, would oscillate by alternative attraction of magnets, 1, and 3, that is controlled by magnetic shields, 27, and 29, and with some help of the springs. Soft iron would turn a wheel, 13, and produce useful work. Below, in Figure 3 and Figure 4, is a second alternative of his motor. When the magnetic shield, 57, is between two opposing magnets, they will come close to the shield, pushed by the springs. When the shield is moved out as in Fig 4, then the magnets will repel each other as they have the same poles. Magnets will perform useful work by turning wheels connected to them by rods. Brown-Eklund generator. Two parallel rotating iron bars will alternatively open and close magnetic flux through the iron core of the generator. Left part is electromagnet for excitation. It could also be a permanent magnet. The right side contains a coil which will convert the fluctuation of magnetic flux into an electric voltage. This generator is very simple and usage of the rotating magnetic shield is very obvious. However, note that rotation of the shield would alternatively allow flux to flow and stop it. Here we have pulsed flux, and the result is that right coil will generate pulsed direct current. To generate alternating current, a more complex setup should be created as shown below in picture 14. It can easily be seen in the above picture, that magnetic shields are turning around its axis and perpendicular to the lines of magnetic force. There are two shield bars perpendicular to each other. The left one is colored in red and the right one in blue. Magnetic flux will flow through the air gap from the north pole of the right magnet towards upper part of the coil, then downwards, and close the loop in the south pole of the right magnet. Once the motor turns shields 90 degrees, the flux will flow from the bottom of left magnet upwards through the coil and back to the south pole of the left magnet. It is obvious that the flow of the flux will change up and down alternatively every time the motor turns the shields 90 degrees. This will induce an alternative voltage. In a document 4 by W. D. Bauer, can be found a table with test results for the above version of a Brown generator. He found the best quotient of efficiency about 125%. They also discovered that a capacitor shunted across the terminals of one of the coils, DC or AC, will provide the necessary field excitation without any other outside source, and for a self-excited model the quotient of efficiency was up to 358%. Their conclusion was, the result is that there is relatively no torque required to rotate the shaft. Apparently the resistive torque on the shaft decreases with an increase in RPM. The generator ran cold, and a direct short on the output coils did not throw a load on the drive motor. Note that it is better to drive a magnetic shield as fast as possible. The importance of the speed will be discussed in the next section. John Bedini's U.S. patent number 6,392,390. The author will not go into any details of Bedini's patent because it can be found on internet. Picture 16 doesn't show the complete patent, as magnetic switch, 13, should be connected to 3 transistors and 5 resistors, which are part of electronics for this patent. The goal of the above picture is to show that Bedini also used magnetic shield logic for his back EMF permanent electromagnetic motor generator. It can be seen that main magnet, 21, can close its flux only through magnetic shield, 16, which has 4 small magnets, 17, and rotate around its axis. These small magnets will not oppose, but increase magnetic flux of main magnets. The change of the flux will cause induction in set of coils, 22, and 23. This induction is rectified by electronics and sent to energize the battery. Importance of high-speed generated voltage. It has been confirmed by experiment that on a conductor with electric current flowing through it, a magnetic force will act upon it, if it was immersed in the field of magnetic induction. Pictured below is a closed circuit with an electrical current I flowing through it, and with lower part of it in the shape of a stick with length L immersed in the field of magnetic induction with magnitude B. Intensity of the force F is proportional to the magnitude of current I, length of the conductor L, and magnitude of magnetic induction B. It can be written as F equal ILB. The above formula is valid only if the conductor is perpendicular to the direction of magnetic field, induction. If the conductor has an angle with the field, then F equal ILB sin, direction of the force is perpendicular to the plane formed by conductor L and magnetic field B. Faraday's law of induction. It is well known that Faraday's law of induction says, induced electromotive force in any closed circuit is equal to the time rate of change of the magnetic flux through the circuit. The change of the flux can be static due to change of the intensity of the magnetic induction, or dynamic due to movement or deformation of the closed contour in the field of magnetic induction. Below is given an example of dynamic induction of electromotive force E, which is the voltage caused by movement of the permanent magnet. Mathematically, Faraday's law of induction is, voltage equals rate of change of magnetic flux. The minus sign in the formula is because of Lenz's law, which says that, induced electromotive force has such direction that in a closed circuit it generates current which by its fields is opposing the change of flux which induced it. That way, induced current causes drag against any change in its environment, therefore the original flux will have to invest work in order to maintain itself. That is the way mechanical energy is converted into electricity in an electric generator. Below is a picture of a school example of a linear generator of direct current. The generator consists of two parallel conducting tracks at a distance L, over which is sliding a conducting bar, under the influence of mechanical force G, with velocity v. Tracks and bar are in a homogeneous magnetic field of induction B, which is perpendicular to the plane of the tracks and bar. On the other side is resistor R, which is there to consume electric energy and to close the current circuit. The intensity of the induced electromotive force E, the voltage, is given by the formula, E equal VBL. For a real generator, with its rotor turning around its axis by angle speed, I am immersed in the field of homogeneous magnetic induction B, and which has n turns of wire with surface of 1 turn S. The formula for electromotive force is given as E equal BNS sin T 5. The formula above is similar to formula 2, and mmber sin T represents changing angle in time between magnetic induction and the surface of the coil. If the number of turns n or the surface S are increased, the length of the wire will be also increased. Each generator is designed for a maximum power which can be delivered to the consumers. The formula for the power is P equal EI 6. If the voltage of the generator E is high, then the current I can be low, and vice versa. Consumer can always adjust the voltage by an electric transformer. If the output current I of the generator is high, then according to formula 1 or 2, magnetic force F, which causes drag of the generator, will also be high, and more mechanic force G must be applied to operate generator. This means that it is not good to allow high current in the generator. However, if the current I was diminished, then, in order to deliver the same power, according to the formula 6, the voltage E must be proportionally increased. By looking into formulas 4 and 5, it can be seen that the voltage can be increased by increasing magnetic induction B, or by increasing length of wire, or turns in the coil, or by increasing velocity V for linear generator, or angle speed for rotor. Because in formula 1, for magnetic force exist magnetic induction B and also the length of wire L, increasing magnitude of the voltage by increasing any of these two values would do no good. Magnetic force, the drag, would be also increased. However, by increasing velocity V for linear generator or angle speed for rotor, the magnetic drag of force F wouldn't be increased at all, and the voltage E would be increased. This way, the generator can still deliver the same output power but with less drag. The less drag means less input mechanical force G for the same output power. However, the problem is that high speed of rotation means that circumference of the rotor will pass longer path. Because energy equals to the product of a force and the path it passed, it also means that input force G will pass longer distance and total energy invested will be the same. This means that this way we cannot create overunity behavior, but only smaller force applied in unit of time. Principles of combining magnetic fluxes. This is the method of merging two fluxes, one from an electromagnet and second from a permanent magnet. There are two ways of enhancement magnetic flux by this method. One is pulling of the flux from the permanent magnet and other is pushing the flux from the permanent magnet in the desired direction and then merging it with flux from an electromagnet. Pulling method is described by Charles Flynn in his long U.S. patent 6,246,561. The above picture shows the magnetic circuit when electromagnets are not active. The flux from permanent magnet is then divided and flows in two directions, to the left and to the right. When the left control coils are turned on with the direction of the current that generate flux in the same direction as flux from the electromagnet, then all the flux from the magnet will go to the left and combine with flux from electromagnet, see picture 21 below. This will enhance the flux on left side by 1/2 of the flux from the permanent magnet. Electric voltage will be taken from the left output coil. The same logic can be applied to the right side of the device as in picture 22. The reason why all the flux from the permanent magnet must go to one side only is because flux from electromagnet cannot be closed through the body of a hard permanent magnet, but must go around. It will meet the original half of the flux from permanent magnet and push it in direction towards its coil. Pushing method has been exploited by a Japanese company called Genesis, and this method they named as hybrid reluctance magnet principle. They used it to construct a DC motor they have named as supermotor. The method consists of interaction of two fluxes. The source of first flux is neodymium magnet enclosed in soft iron, and the source of second flux is the electromagnet, which is magnetized periodically when necessary. Magnetization of electromagnet is in such a way that its flux is opposing the flux from the permanent magnet. The magnitude of flux of electromagnet should be a little bit bigger than flux from permanent magnet in order that it can prevail and push first flux in desired direction. This way two fluxes will combine their intensity and flow together in desired direction, usually towards another piece of soft iron which is movable and attracted to the device. Below is the picture of the complete device. The lines on picture 24 show magnitude of fluxes alone and combined together. Below are displayed three cases of fluxes but without the soft iron bar above the device. When the electromagnet is turned off, only the first flux, from permanent magnet, exists and it closes itself through the core of electromagnet. Permanent magnet and the core of electromagnet attract each other. This is the first case. In second case, the electromagnet is turned on and its flux is bigger than flux of permanent magnet and has opposing direction. It will be able to push flux of permanent magnet outside and both fluxes will combine and flow through the air. Attraction between the permanent magnet and the electromagnet core will exist only if flux of electromagnet is much stronger than flux of permanent magnet. In the third case, both fluxes are equal and opposing each other. If iron cores of permanent magnet and electromagnet were not saturated, weak fluxes, they wouldn't repel nor attract each other, powerless status. If fluxes were strong and the soft iron was saturated, then the iron cores would repel each other. If a bar of soft iron is added to the case 3, then flux from permanent magnet will easy close along the bar. Iron bar and the core of permanent magnet will attract each other, but there will be no attraction between permanent magnet and electromagnet. That attraction can be made if iron bar was added to the case 2. This time some attraction between permanent magnet and electromagnet will exist and attraction between iron bar and permanent magnet would be stronger. The problem with the case 2 is in the fact that for creation of larger flux in electromagnet than in permanent magnet, bigger electric current should be used, and that is not energy efficient. Energy efficiency can be increased by diminishing air gap between iron bar and permanent magnet, by using soft iron with greater value of magnetic flux saturation for iron bar and permanent magnet than for electromagnet, and by making line L2 shorter than line L1, smaller magnetic path and resistance. The author found this concept interesting as it looked to him like a magnetic transistor effect or effect of using pendulum, as did Mr. Veljko Milkovic in his two-stage mechanical oscillator. Once pendulum was initially raised to an angle and released, it was easy to maintain oscillation by adding small energy. This adding small energy looks like electromagnet pulse in this device, and initially raised pendulum looks like permanent magnet which was initially magnetized some time ago. People interested in mechanical devices can find more about it on the official site of Mr. Milkovic 3. The author experimented using old transformers and found that it is very sensitive task to create a proper device with pushing fluxes. If electromagnet and permanent magnet didn't agree, effect would be hardly noticeable. Author also tried to create device where cores of electromagnet and permanent magnet were connected to each other to avoid powerless state or repulsion of the cores, and to use device as pulsed electromagnet with better performance, see picture 26. Unfortunately, he found that in that case effect of pushing fluxes, although worked correctly, had much smaller attractive force than electromagnet alone, once the core of permanent magnet was cut, see picture 27. This means that usage of this device is sensitive and is not for all purposes. This concept is interesting to investigate. Genesis Company is selling DC motors which have 4 times bigger output power than the same type of standard motors with the same input power, see their site 5. First law of thermodynamics and surplus of energy. The well-known first law of thermodynamics, which says that energy in a closed system can change from one form into another and cannot be destroyed or created, failed as such not only in the case of overunity electromagnetic machines but also in some other areas. The main reason is because the idea of a closed system has no sense at all. It is enough to be reminded of cosmic rays which can penetrate Earth's soil several kilometers, various radio waves which penetrate the space and carry some energy like sun, wind, gravitation force, and also energy in the decaying atomic structure of the matter. The problem of energy balance of a river. The author found interesting an article on the internet concerning calculation of kinetic energy of water for hydropower plant on the river Rhine in Germany. It was an old problem, from 1932, described by Ludwig Erbrand 6. Erbrand found that the power plant of Rheinfelden was close to an island and directly utilized the flow of the Rhine River's water, feeding it through turbines without the use of a dam. It was able to generate the same power as nearby plant constructed in 1926 at Reiberg-Schwoerstadt, which had a dam 12 m high. He found that water of Rheinfelden plant flowed faster than other water in Rhine River because of the island. Water with greater velocity will have greater kinetic energy than slow-moving water if the same quantity of the water is moving along the river bed. Below in picture 28, can be seen the situation. Erbrand wanted to patent his findings, but wasn't able to do it as the first law of thermodynamics was official religion in the science at that time, and for many it is also at present time. Nobody believed that fast-flowing water in narrowed river bed could have more kinetic energy than the rest of the river. It would oppose the law of conservation of energy. Explanation of this was found in the works of Victor Schauberger, known as the water wizard. Any river has more or less some whirls inside it. Whirls which moves in the direction of the river are healthy ones, as they do not dig river banks. They consume heat from the water and make the water cold and free from unhealthy bacteria. They also carry sand and gravels and keep river beds deep. In order to maintain whirls, the river must meander. Straight paths like in man-made channels are not healthy for the rivers. These whirls are carriers of extra energy which can be released when necessary, like in the case of narrowed river banks. So, the law of conservation of the energy could still be valid for the river if its temperature variations and turbulent movements were taken into energy balance. An interesting fact is that in Chinese culture all house roofs are curved in order to prevent rain from going down in straight lines, but rather to move in curved path. In their art of feng shui, curved lines are highly appreciated and straight lines were deemed as poisoned arrow. The reason for this was an attempt to collect some energy or qi which moved in curved lines. Because in human or animal body there is not any straight line, this logic has some sense. The possibility of cosmic ether as energy source. Many constructors believe that permanent magnets can pull out energy of cosmic ether and give it to the generator. The reason for that would be the existence of microcurrents in a permanent magnet, which are closed circuits of electricity flowing through it and can pull in the energy from the environment. The idea of ether was supported by Nikola Tesla and John Worrell Keely, among others. Scientists usually demonstrate Einstein's idea of gravity as a kind of deformed space by using a cloth or sheet of paper and then pushing finger in the middle of it. They forget that without that cloth or the sheet of paper they would not be able to demonstrate anything. The author believes that the idea of deformation of empty space doesn't make any sense. Only if there is something in the space, either sensible energy field or lump of matter or at least cosmic ether, which is movable and subject to some deformation, then Einstein's idea could make sense. His mathematics could be true, although the space wasn't deformed but the stuff inside it. No scientist gave an answer as to what exactly is electric charge, of an electron or a proton. They defined it as a spin of corpuscle, which means a rotation around its own axis. If we imagine a corpuscle either as small rotating ball or as a whirling wave, still it is not clear how attraction of electric charge happened in an empty space. Author can easily imagine attraction in the water. Any whirl in the water can suck something in it. Using the same logic, author can easily imagine attraction of an electron or proton if they were whirls in cosmic ether. They would create deformation close to itself, like the whirl in the water, and be able to keep sucking anything close to itself. Using this logic would be easy to explain why an electron emits a photon of light when it changes its orbit and goes down close to the core of the atom. Going down would mean squeezing cosmic ether around the core of the atom, like squeezing a hose with water. A portion of water must go outside. Conclusion: the goal of this work was to present basic ideas used by some inventors to construct their overunity machines. There are many more inventors in this field who used similar ideas, basic or combination of two or more basic ideas in their work. The author has seen many patents from this field and probably has never seen many others. However, the most important thing was to present these ideas in some logical order that most people can grasp. These things are not yet accepted by official science, and the author does hope that this work could make some contribution in breaking dogmas worshipped by many. It has been seen that there are many ways to unbalance the magnetic force in order to extract useful work from a magnet. Also, the necessity of the usage of new materials for cutting losses in iron shields has been emphasized. Importance of high speed has been discussed for using magnetic shields, for using high voltage, and also in using hydropower from the rivers. Method of combining fluxes has been shown as a separate principle. However, fluxes do combine even with other methods, as magnetic field must close itself and it will flow through the nearest iron core either of the stator or of the rotor. Then it will have an impact on the nearest coil either in positive or negative way. For people interested in practical work and without experience in this field, the author would like to recommend set of documents from Patrick Kelly 7, who described many patents from all over unity fields with a lot of details. References: 1. Peter Lindemann, Doctor of Science, The Free Energy Secrets of Cold Electricity. 2. Jovan Marjanovic, The Case in Electromagnetism Where Newton's Third Law is Not Valid and Getting an Energy Surplus in an Electro Generator. http://www.veljkomilkovic.com/images/jovan_marjanovic_the_case_in_magnetism_where_valid.pdf. 3. Official site of Veljko Milkovic, www.veljkomilkovic.com. 4. B.W. Bauer, The Brown-Eklund Generator, Part 1. http://www.overunity-theory.de/ekelund/ekelund1.htm. 5. Genesis site, http://www.genesis-corp.co.jp/e/e507.html. 6. Ludwig Erbrandt, Understanding Water Power. http://www.hasselberger.com/techno/techno_1.htm. 7. Patrick Kelly, A Practical Guide to Free Energy Devices. www.free-energy-info.co.uk. Published in Novi Sad, Serbia. November 12, 2009. http://www.veljkomilkovic.com. Jovan Marjanovic. Bachelors of Science in Electrical Engineering.